Yeah.
Star Walls now?
We're going to try it again. Should work.
Clicker? Hi, we're the Star Walls, and we're doing the asteroid mining challenge. And we actually plotted out a whole mission. So we chose a target, which is this near-Earth asteroid, 2000 SG 344. It's only about 37 meters big. It's a couple hundred megatons. And we're actually going to bring it back to Earth. So you can see all the data from JPL about the flight. We're actually leaving on the 4/22/2024, and the duration of the actual mission is about 1,000 days. So you're looking at about 3 to 4 years, right around there. So we have a mothership. You can see over here, we got a nuclear reactor on the right-hand side, and then the actual mothership. And then we've got a bunch of various drones that will come off of it. You can see in the picture, the little CubeSats are sitting off the side of the asteroid. This mothership has a lot of the capabilities, all the computing capabilities, all the control capabilities are on the mothership to control the drones. The drones are not autonomous. They go through the mothership's communication systems. So orbit and transit, as you can see, the little blue line is, or the blue dot is our target. And as we approach the 2028 May, we actually get closer and closer, and that is the actual approach date, which is May 2028. And that distance is only 0.02 AU away. So at this distance, we can actually communicate with our satellite. And you can see now we're actually approaching very close, and then we get into 2028, and there's a close approach right there. That picture is the only picture we have of that asteroid. It's that little gray line there with the arrow pointing to it. The other side, right now, it's on the other side of the sun, so we won't see it probably for another 3 or 4 years, I think is their prediction. And Arecibo won't pick it up before, we'll pick it up just slightly before that. So we got impactors and drones aboard our mothership. The little blue ones at the top there are actually a sensor drone. So that'll actually stand off with the mothership from the asteroid and actually monitor the mining drone. The red one is a mining drone. It'll go around the surface and pick up regolith and then deposit it into the green, which is a mass launcher slash smelting device. So the mass launcher drive, the drone drops the regolith into the hopper, and then the electroplates actually statically move the material between the hopper and the centrifuge. There's the centrifuge. The centrifuge extracts some of the heavier material, and we're left with the slag. We also produce oxygen and a little bit of hydrogen. And we use that oxygen to fire the cannon. So what we do is we take the slag from the centrifuge, we compress it, we load it into our basically big potato gun, and fuel it with the oxygen and fire it. This allows us to actually 90% of our delta V change to bring the asteroid back to Earth can come from the mass launcher. And that actually uses only 7% of the mass of the asteroid to do 90% of the delta V changes. We've also got, we're in an orbit for a gravity tractor, so we can adjust it a little bit that way. We're slightly attached, we use an ion engine, so we can apply some pressure that way. But the main thing is the mass launcher. So we're going to return this rock to the L1 position, which is the bounce point between Earth and the moon. That way you can take the material either way. If you're going to build on the moon, you don't want to bring it all the way down the Earth and then have to dig out of that gravity well. So we'll leave it at L1. There's no satellites there. That position's actually got dust cloud and debris clouds already there because of the point. And as I said, it's only, the distance from Earth on May 7th is only 0.205 AU. So we're not going out far. We're not going out to the asteroid belt. This is a near-Earth asteroid that we're picking up. Here's all the resources we did, and here's our team. I want to thank everybody at NASA Glenn. I want to thank the Dragonfly team for helping us on our side. And my whole team and the team here, we've done awesome. I think we've designed a mission that is actually capable versus what, if you go out to the asteroid belt, that's a lot of delta V to change. So we're real close.
We have the model, so if you want to look at it, come over to our table. You can see kind of how stuff comes together. Yeah, that's about it. Anything, guys? All right, thank you very much.
Stellar Taylor with Yeomans on deck.